Question last time?
Yeah, we did this one.
And this one? We have done that. Like we have to start with question 2 if I'm not wrong.
Yeah.
Or we have completed part C. Like I'm sure that we have done part A and B, but I'm not sure with part C. Have we done that?
No, we haven't done this one.
Okay, so start with part C.
Okay.
So it's a graph given, and it's given give two conclusions that could be made from the data in figure 2. So by looking at the graph, what can you deduce from this graph that you have to answer?
Efficiency.
Just by looking at the graph, like what can you deduce it? So what's your first answer? Like you have to give two conclusions. What's your first conclusion? Hello.
Hello.
Yes. So what are your conclusions from this graph? Like simple. If you see a graph.
The most.
Yes, yes.
Yeah.
Yeah, I'm saying like if you see any graph, the first thing is you have to see that graph is made between which two variables and how they are changing with respect to another variable. How one variable is changing with respect to another variable. That is your first conclusion. That should be always your conclusion. So see what's happening with efficiency with respect to speed. That will be your first conclusion.
Hello.
Yes. Can you hear me? Hello? Hello?
It's cutting a bit. Hello.
Can you hear me now?
Yeah.
Okay. So tell me what are your conclusion for part C by just looking at the graph. What's your conclusion? How curve is moving? That you have to describe here.
I'm not
Hello? Your voice is breaking actually.
sure.
Hello?
Hello.
Your voice is breaking. I can't hear you properly.
Oh, I'm not sure. 'Cause I couldn't really hear.
Okay. You can hear me properly? Is that so?
Um. Yeah. Now I can.
Okay. Okay, so the two conclusions are, the first is that if you see that as efficiency is increasing, the speed is also increasing. Is this clear? Hello?
Yeah. Yeah.
Yeah. So if you see that if efficiency increases, the speed is also increasing. And
Mhm.
second is that the curve is quite constant. If you look at the curve, okay, at some
Oh.
point it tends to move at a constant value, right? At the very end, see, if you extend this graph, This is graph, and definitely it's taking turns, and it's achieving a constant value. After this, it will achieve a constant value. If you extend this graph beyond the 0.35 meters of speed, meter per second of speed, maybe 0.4555 whatsoever, it's achieving a constant value, right? And this constant value is somehow between 50 to 55%, which proves that efficiency of any machine can never be greater than 100%. That are the two conclusions. So first is that if efficiency increasing, or say if speed is increasing, the efficiency of the machine is increasing. And second is it's achieving a constant value, which proves that efficiency can never be greater than 100%. It's always way lesser than 100%. That are two
Okay.
conclusions from this graph. Clear?
Yeah.
Yeah. You can write it down like whenever you feel like
Okay.
it.
Yeah.
And you can move on to part B. Okay, read out part D. Give the main way that the give the main way that the motor is likely to waste energy.
Would it be waste energy through heat?
Sorry?
Um, would the motor waste energy? Would it be?
No, give the main way that the motor is likely to waste energy. How it can waste energy?
How can what?
It can waste energy. Waste energy is definitely the elevation of the temperature. By what factor? Like why it's producing heat energy? Why it's producing waste energy? Give the main way that the motor is likely to waste energy. Main way. How can it waste energy? What's the main way it can waste energy?
Um,
Simple. When it releases the waste energy, what happens to the surrounding that you have just told? Simple. Tell me.
hello.
Yes. First tell me what's waste energy. We have studied last time. What's waste energy?
Energy that is not needed.
Yes. And how it's dissipated in the environment. In which form?
Um, what do you mean? Like,
In which form? Like if I say it's a kinetic energy or waste energy, or potential energy or waste energy, can I say that? No, it's a useful energy. Simple waste energy is always a thermal energy. When you touch a body and you can feel the temperature, elevation of temperature, that means particular machine is dissipating energy. It's a waste energy. I have given you the example of a mobile. When you use your mobile for a long period of time, you can feel the warmth, right? Like a hotness. So that's a wasted
yeah.
energy. So waste energy is always thermal energy. So if the question is give the main way that the motor is likely to waste energy is by heating the surrounding. Clear?
Hmm.
Okay. I think it's better if you write it and move on to question number. Part E. Okay. Read out part E and answer me. Efficiency. You know the formula for efficiency, right?
Yeah.
What's formula for efficiency?
Um, was it? Um,
If you have notes, like last time we have covered efficiency. So if you have notes, you can see the formula of efficiency formula. So what's the formula?
was it useful overall energy and then times it by 100?
Useful energy divided by total energy times by 100. That's efficiency percent. Okay.
Yeah.
So now read out the part E and calculate the efficiency.
Efficiency be 50.
Okay. But the question actually is given as, and first of all, whatever in your numerator it should be in denominator. That means if you are doing 2.5 divided by 5 into 100, it's not correct because 2.5 is weight, that means it's force, and this is power. So your efficiency, like whatever be here and here, both have same unit. They should have the same unit. So it can be
Oh,
useful energy divided by total energy, or useful power divided by total power, or multiplied by 100. Okay. So if your
mm-hmm.
input power is 5 watts, you have to calculate the useful power. But actually, if you read out the question, what's written here is that while the total power input of the motor was 5 watts, when total input power is 5 watts, the motor could not lift the 2.5 newtons of weight. That means though the input is 5 watts, it's written it could not lift, right? It could not lift, that
Yeah.
means it's not able to lift. So it doesn't matter how much power we are providing, it's not doing any kind of work, it's not producing a useful energy or useful power. That means your useful power is zero. Is this clear? Is this point clear why it's useful power? Say for example, you are eating and eating, the whole day you are eating, but you are doing no work at all. So what's your efficiency? How much you are efficient? You're 0% efficient because you're not doing any work. The same thing is here. Though this is motor. Actually, what's efficiency is how much energy we are supplying, and out of that, out of like taking that energy, how much energy is converted into useful work by this machine is actually its efficiency. Simple, if you see the word efficient, it's there, like it tells about a person how efficient is about his work, how perfectly he can do his work. That's the efficiency of that person. Same thing is for the machines, how efficiently it's doing its work. So if suppose there are two machines, you have to answer this. There are two machines. We
Mm-hmm.
are providing 10 watts of energy to both the machines. That's the input energy. It can be through electrical, mechanical, whatsoever. And it's converting 10 watts of energy and it's actually producing, say, 6 watts in it, or simple form. And it's 5. Which machine is more efficient?
Um,
The first one or second one? Which is more efficient?
the second.
No, oh, a simple example. There are two persons. This is person 1 and this is person 2. I have given both 50 pages to type. Okay, that's my
Yeah.
input, 50 pages. After 1 hour, this man has typed 30 pages and this man has typed 20 pages. Who's more efficient?
30.
Yeah, because he has produced more work from the given. Same thing, if I ask you, instead of person, these are the machines. And instead of pages, the energy is given to them, which is say 20 joules instead of like say 50 joules. There I was giving 50 pages to the person, it's 50 joules of energy provided to the machines. And this machine has produced 30 joules out of 50, and this machine has produced 20 joules out of 50. Which is more efficient?
The 30.
Yes, because this machine is actually producing more work. Why I'm providing input energy? So that I can get some output. Now simple. Suppose I have purchased a heater, okay, a room heater. I turn on the heater and nothing happens. That heater is not heating the room at all. How efficient that particular heater is? What's the efficiency? Not like don't calculate in percentage. You tell me, is that heater efficient or not? If it's not heating the room at
Um,
all. Okay, simple. What's the main purpose of any machine? Why do we purchase machine? Any machine. Like take the example of digital clock or computer or mobile. Why do we purchase it? Like
why do we what?
purchase them. Why do we buy them?
Wait, can you repeat it, please?
Okay, I'm saying why do we buy machines? Why do we buy the basic machines like whether it's a coffee maker
Um,
or so on?
any, so we can produce stuff.
Yes, so that we can get the work from you, right? Take the example of
Yeah.
mobile. So I purchase mobile for many uses. Okay, like to talk or to use internet or whatsoever. Suppose if I purchase a mobile and I turn on the mobile and it's not working at all, is it useful or not? If it's not working, it's not turning on. Is it useful or useless mobile? Tell me. Are you getting what I'm saying?
It was cutting a bit.
Okay. Can you hear me now properly? Yes.
Yeah.
Okay. So I'm asking, if suppose I have purchased a mobile, okay, I
Yeah.
turn on mobile and it's not working at all. It's not turning on. So is my mobile useful or useless? If it's not working at all.
Can you repeat it, please?
I'm saying if my mobile is not working at all, it's not turning on, it's not doing
Yes.
any work, is my mobile useful or useless?
Useless.
Yes. So what I'll do, whether I'll give it for repair or whatsoever, but it's of no use. Simple. Because it's not producing any work. My desired work, I want it to be turned on, I want to call people, but it's not working at all. So it's 0% efficient. Is this clear? Why it's 0% efficient? Because it's not
Oh,
producing any work.
yeah.
Same thing is here. The efficiency is useful work over total or input work or energy multiplied by 100. How much energy is being produced, how much work is being produced from the input energy. Like take the example, I just keep on charging my mobile, I'm just providing input energy by charging my mobile, but still it's not turning on. So it's not producing a useful work because it's not turning at all. So useful work is here 0. Total energy is, it can be any joules. So my efficiency is 0%. Doesn't matter how much energy I'm providing to my mobile, still it's not working. So it's 0% efficient. Same thing is here. The input is 5 watts. 5 watts of energy is being supplied to the motor, but still motor is not able to live. It's not working at all. So its useful work is 0 divided by 5 multiplied by 100, which means efficiency percent is 0%. Is this clear?
Oh, okay. Yeah.
I think it's better if you write it down.
Yeah. Right now.
After this question, we can move on to question number 2.
Okay, I finished writing that.
Sorry?
I finished writing.
Okay.
Um.
So now read the question 2. Different energy sources are used to generate electricity. Use the words from the box to match the correct energy source. Each of the description given in the table. Okay, each of the source given. Okay, you have to write this.
Okay.
It's so simple. What you have to do is just write these 5 words: biofuel, coal,
Oh,
geothermal, nuclear waste, and then I'll move on to the next page.
okay. All right. Yeah. Yeah. I've written down.
So according to the description, which is that energy source? You have to answer. What is the energy from the Earth's core used to heat water? Hello?
Okay.
Yes. So answer the first one. What is that energy? Energy from the Earth's
Um,
core is used to heat water.
would it be geothermal energy?
Uh, which is geothermal energy? Hello?
The first one.
Yes. The second one?
Okay. Um, would that be nuclear?
Yes. And the third?
Um, is that
Which is?
bio? Is it biofuel?
Yes, that's correct. Now read out the next part. Its energy can be stored in a pump storage power station. The figure shows a pump storage power station. When electricity is needed, the water in the high level reservoir is allowed to flow to the low level reservoir. The flowing water generates electricity. Use the correct answer. Okay, so these are the words and you have to fill the blanks.
Okay.
So water in the high level reservoir stores dash energy. Choose the correct word.
Does it store electrical energy?
It's gravitational potential energy. So gravitational potential energy is always due to the height or due to the position of an object. That is the energy because of the position of the object. Like take the example kinetic energy, it's because of the motion of the object. Same as gravitational potential is first it's a stored energy and second it's because of the position. Last time like if you have notes or if you have taken the screenshots I have written there that it's
Mm-hmm.
because of the height and it's a stored energy. So higher is the object, higher it has potential energy.
Okay.
Okay, next. So tell me what's the flowing water has what energy out of these remaining four?
Is it Is it kinetic?
Yes. So I told you the energy because of the motion. So it's a flowing water, that is what is flowing, it has motion, so it's a kinetic energy. Next is water turns the turbine which is connected to the generator. The generator produces some dash, this is wasted energy. So remaining are electrical, nuclear and sound. Just think that because of what a generator is producing, that is a wasted energy. Nuclear, electrical or sound. Pick the first or any one of these.
Um,
First, tell me what's the work of generator? What a generator does? What's the use of
would it
generator?
be? Pardon?
Yes. So I'm asking what a generator does. What's the work of generator?
What is the what?
Generator. You can see it's written as the water turns the turbine when it's connected in the generator. The generator produces some. So first you tell me what's the work of a generator? What is a generator? What do you mean by generator? So what's generator?
Um, would would sound be the wasted energy then?
Yes. It's a
Okay.
sound energy. Because generator produces electrical. Okay. Generator produces electricity, but it's a useful work. When it comes for the wasted energy, so it's a sound energy.
Okay.
Okay, have you screenshotted it?
Yeah, it's okay. Yeah.
Okay, then read out part C, and here you have to calculate efficiency. Okay, so you have to calculate the efficiency of the pump storage power station. So you know it's output energy divided by input energy, or
Yeah.
useful power divided by total power multiplied by 100. Same you have to do here to calculate efficiency.
Would the efficiency be 90?
What's efficiency is 9%? Yes, that's correct. Okay, now for second part, calculate how much power is wasted by the pump storage power station. So you know the relation
Would that
between,
be
yes, yes. How much is the wasted power?
um would it be 60?
Yes. And
Okay.
for C, how is the temperature of surrounding affected by the energy wasted by the pump storage power station?
Um, would the temperature increase?
Yes, that's correct. Okay. C question number 3. So you have to calculate the energy transfer to the surrounding from the water. Okay, let me tell you, there's a formula to calculate heat, which is Q is equals to, I think it's not required here because we're not doing these kind of questions as of now, but still, let me give you the formula. This is the energy transferred to the surrounding or energy gained or lost. This is mass of the object. C is the specific capacity and dt is the temperature difference. We'll do questions on that heat energy and all that, but as of now,
Yeah.
we're just doing questions of an energy transfer and the energy form, like changing the forms of energy. So mass, and this is a specific heat.
So you just have to times them all together.
Yeah, you have to multiply all them together. Mass multiplied by specific capacity multiplied by temperature difference. Now you have formula and you just put the values right there to calculate the energy transfer to the surrounding.
Would that be 46,200 joules?
Yes, that's correct. Okay, now read out this part B. And what you have to do, you just have to pick the correct option. So which is the correct option?
Um, would it be the first one?
Energy. No, it's C. Why is the total energy input to the kettle higher than the energy used to heat the water? Simple. Yes. Look out the question. Why is the total energy input higher than the energy from the surrounding energy used to heat the water? This is. This option is correct.
Wait a second.
See, it's given
Okay.
as why this input energy is actually lesser than the output energy. Because energy is what? The energy used to heat the water. Because its energy is used to heat the kettle, that energy is actually heating that kettle. Okay? It's not absorbed from the surrounding at all. The second option is correct. And the kettle is more than 100%, this is not true at all. I've told you that in real life efficiency can never be equals to 100, but theoretically it can be equals to 100, but whether it's theoretical or practically it can never be greater than 100%. Okay, it's totally
Okay.
impossible. Okay, so next question, and here you have to suggest two reasons. So first read out the question properly and then give me the two reasons.
Okay.
Is the question clear? Hello?
Hello?
Yes. Is this question clear?
Yeah.
So just
Um,
two reasons.
so will they continue as it will be cheaper as it's 7.8?
Yes, that's correct. And second, because you have to give two reasons.
Um, they could invest in money because they're
You can say they are more reliable, right?
selling it to the countries.
Yeah.
Pardon?
Yes, yes, that's correct. Okay, for part B, give two disadvantages of generating electricity using nuclear power stations. So, what can be the two disadvantages?
Um,
See, definitely, if there's a big industry that are using some materials after utilization, there are some waste materials also. This is clear. Suppose there is a factory which produces, say, iron spheres. It's producing iron spheres. So it takes iron billets or the rods, and definitely some of the materials gets wasted. So they dump it or they reuse it whatsoever. Same as if there's a nuclear power plant and it's utilizing a nuclear fuel, there should be a nuclear waste and they have to dump somewhere, whether it's on land or in water. So that's very dangerous. So first thing is the radioactive waste or the nuclear waste produces radioactive, like it produces the rays, alpha, beta, gamma, which are very dangerous. And secondly, if they decompose those wasted anywhere, that's dangerous for that ecosystem also. Like if they're decomposed in the land, it makes the land barren. If they decompose in water, it just destroys or kills the marine life there. So the nuclear waste is very much dangerous. That's the first point. Is this clear?
yeah.
So you can write it here, because of the nuclear waste as a key point, and inside you can describe it, that how nuclear wastes are dangerous. Second is, you can say it's non-renewable. So you have to take, or at one point they are going to diminish, or you can say they are going to end, because it's non-renewable. You can't renew it. Like there's a hydropower, electric power plants, or solar power plants. They are renewable, so you can use them anytime. It's not renewable, so it's limited. Okay. So these are the two reasons.
Yeah.
You can take screenshot, then I'll move on to the next question. Okay, see part C, and you have to calculate useful power output. Efficiency is given. Simple, put the values in the formula. Okay, have you calculated useful power output? Hello?
I'm a bit stuck on that one. Hello?
Yes, for part C you have to solve.
Yeah, I'm a bit stuck on that one.
Okay. If your voice is breaking, I can understand that you have done or you are doing definition. Hello?
Okay?
So have you completed or are you doing this question?
I'm a
I don't understand what
bit
you said.
stuck on part C.
Actually, your voice is breaking as I literally can't understand what you're saying. Hello?
Okay?
Yes. So what were you saying?
I'm a bit stuck on part C,
Okay.
how to rearrange that formula.
Okay. So first is its efficiency percent is what? Useful energy over input into 100. Now start putting the value. So it's given as a panel of solar cells has efficiency of 0.15. So it's not efficiency percentage given, it's just the efficiency given. Okay, there's a difference between. If it's percentage given, then you have to use formula multiplied by 100. But here it's 0.15 given. It's not in percentage given, so it's just useful over input is equals to efficiency. Is this clear?
Kind of, yeah.
Actually, if you have to calculate efficiency, simple efficiency, then it's useful energy divided by input energy. When it's efficiency percentage, then you have to multiply it by 100. Simple. So if in place of 0.15 it's written as 15%, then you have to use this formula where you have to use multiplied by 100. When it's not percentage, when you can't see a percentage anywhere and it's 0.15, 0.2, 0.3 somehow, then don't use multiplied by 100. Just eliminate them. Is this clear? When in the question it's given as percent, efficiency is 20%, 30%, then you
Yeah.
use this formula multiplied by 100. When in the question is given as a particular machine has efficiency 0.45, 0.32, something like that, then don't use multiplied by 100 in the formula. Okay.
Mhm.
Now efficiency is given as 0.15. It's 0.15 is equals to the total power input to the panel of the solar cell is 3.2 kilowatts. Calculate the useful energy. So its total input is 3.2 and you have to calculate the useful power. So let I name it U. Simple. What I will do, I just cross multiply. So useful power is equals to 0.15 multiplied by 3.2. Clear?
Yeah.
So multiply this and give me the value. What's 3.2 multiplied by 0.15?
Would it be
Just multiply 0.15 multiplied by 3.2.
0.48?
Yes, it's 0.48. And 0.48 what? Like what's a unit?
Um, KW,
It's kilowatts, right?
KW?
It's in kilowatts. So your answer is 0.48 kilowatts. Okay. Is this question clear?
Mm-hmm. Yeah.
Okay, now read out the next part and use information from table to suggest why. Read out the question what they're asking and give me the answer. So as given, some scientists think that having a low manufacturing cost is more important than improving the efficiency of the solar cells. Use information from table 2 to suggest why. Like why they think that having a low manufacturing cost is more important than improving the efficiency of solar cells.
Because if it's a low cost, then you can buy more of them, and then the efficiency will be big anyway because there'll be more of them.
Yes, so simple you can say the higher the efficiency, higher is the cost. Okay,
Yeah.
that means more electricity could be generated from same cost. So simple. In short, you can say higher is the efficiency and higher is the cost. That's the main reason. Okay, so like you can take a screenshot. Okay, and that's it for today. The rest of the
Okay.
questions we'll do in the next class. And you just keep on
Yeah.
revising. You just revise all the formulas and all that stuff so that we can do the questions in the next class.
Okay.
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 Thank you. Bye.
Bye.
You are currently the only person in this conference.